curve sketching, and that's where we're headed. Now we're going to put everything together in terms of pictures. Then we're going to move to applications of this stuff. Reminder of some algebra, and that's vertical asymptotes. Vertical asymptotes are caused by a division by zero, which means that a function must have a denominator. If it doesn't have a denominator, it can't have a vertical asymptote. You have to have a division by zero. And if I take a look at the two pictures and some of what it tells me, this gives me that the VA, or vertical asymptote here, is x equal 2. If I apply calculus to this, I will notice that the limit as x goes to 2 from the right of f of x, and in this case is infinity since it's going up, and then that the limit as x approaches 2 from the left of f of x is minus infinity because it's going down. And by the way, from a calculus point of view, that technically speaking is how you know you have a VA. Now, the other thing that I look at when I see this guy is that if I go from left to right, he's coming in decreasing, and then on the other side of the VA comes back in decreasing. This says that f prime is always negative. Decreasing, decreasing, always negative. So I would see on my number line, I'd have to put the VA into place, because if I didn't do that, it wouldn't make any sense. And it would be decreasing followed by decreasing. Now, the other thing I notice is this guy on this side is concave down. And on this side, he's what? Concave up. So again, if I look at f double prime, the VA plays a role. There's a change in concavity across the VA. So def double prime would be negative to the left of the VA and positive to the right of the VA. This whole thing is to save you from what I got hurt on time and time and time again as a student, is I forgot to include the VA as a critical number. And if I don't, I'm really going to mess up on concavity. And I could mess up on increasing and decreasing if I don't include the VA. More on vet concavity than anything else, because this guy's always decreasing, I should be okay. But if he was increasing on one side, decreasing on the other, then I have a little bit of a problem. Now, if I take a look at the second example, here my VA is x equals 0. And if I take a look at the limit as x goes to 0 from the left, it's equal to infinity. And I take a look at the limit as x approaches 0 from the right, it's also infinity. That says I have a VA because it's going to infinity to the left and the right of some numerical value. Now, if I take a look at what else I've got going, I notice that as I come in on X, I'm increasing till I get to 0, decreasing after 0. So if I look at F prime, he lives and dies by the VA. That says on the left-hand side of the VA, F prime is positive, and on the right-hand side of the VA, F prime is negative. Now if I look at the other piece that I know, and that is concavity, this guy is concave up till he gets to the VA, and then he is concave down after the VA. So again, if I look at the, oh, I'm sorry, he's not concave down, is he? He's concave what? Concave up. So if I look at, again, the VA, which I have to include, and this is F double prime, it's plus followed by plus, so concave up followed by concave up. Now that's working directly from the image, from the picture. Pulling the picture away, we have the definition of, the calculus definition of a vertical asymptote. The line x equals c of a vertical asymptote of the graph of f of x is either the limit as x approaches c from the left of f of x is infinity or negative infinity, and the limit as x approaches c, that's a numerical value, from the right of f of x is either plus or minus infinity. That's how you know you have a VA. Take the limit from the left, it's either going to plus or minus infinity. Limit from the right, it's either going to plus or minus infinity. That would be the strict definition of a VA from a calculus point of view. For us, we don't have to, well, we do have to worry about it a little bit. So here we go. Find the vertical asymptotes. Vertical asymptotes is basically where the denominator can't be 0. It's a division by 0. But this is where we have to be very, very careful. That x value cannot be a 0 of the numerator two as well. Why not? What if that x value was a 0 of both the denominator and the numerator? It would be a whole. Which means it's not a VA. So I have to be very careful when I'm looking at vertical asymptotes that it is a vertical asymptote. That's why they have that definition there. If it's a whole, if you're coming from the left, you're not going to go to infinity. You're going to go to the value of the whole. You're coming from the right, you're not going to go to infinity or minus infinity. You're going to come to the value of the whole. For us, it's easy. Just put the dang number back in. If you get 0 over 0, what do you know you have? Oh. Don't have to do limits, just do algebra. And sometimes it's easy to see. So here we go. What is the 0 of the numerator? What makes the numerator 0? 0. So as long as I don't get 0 in a denominator, what I have is are vertical asymptotes, right? So as long as it's not 0, I'm fine. So I need to take x squared plus 2x minus 15. It can't be 0. That's going to be your domain restriction as well. And so this is x plus 5, x minus 2 can't be 0. 3, correct. That's how I got the 2 in the middle. Or x can't be negative 5, x can't be positive 3. Well, this says, since neither of these are zeros of the numerator, that x equal negative 5 and x equal positive 3 are vertical asymptotes. As long as it's not a 0 of the numerator, it's a vertical asymptote. See, a lot of these kinds of itty-bitty little details we didn't have to concern ourselves with in college algebra. Now, we kind of went along our merry way, didn't worry about it. We have to worry about all these little itty-bitty things here in terms of detail. Calculus is a very detailed course. Find the VAs. Well, I got a denominator, so there is a potential of having a VA. So I'm going to be looking where x squared plus 3x can't be 0, or x times x plus 3 can't be 0, x can't be 0, x can't be negative 3. Are they both VAs? No. Who's the VA?
0.
Yeah. X equals 0 is a VA. X equal negative 3 is a 0 of the numerator. So it is a whole. Just have to be very careful.